students, welcome back. Now let's go to section 2, Bayesian analysis. Here's a reminder of the multiplication rule. The probability of A and B is the same as probability of B times probability of A given B, or the other one. And this time, let's focus upon this expression. You see, in alphabetical order, usually A takes place first and then B. So let's suppose A took place first. So we know A already took place. So that goes to a condition. Let me repeat my expression again. Let's focus on this, the second rule. And let's consider it in alphabetical order. A first and then B. So, how did A take place? That probability is right here. Apply that. Alright, it now took place. Now we have to consider B, but you see, A already took place. So that becomes a condition. So we have probability of B given A. Here's an example problem. An auto insurance company classified its customers as minimum risk, low risk, moderate risk, and high risk, depending upon their driving records. The company estimates the probabilities that of all listed drivers getting into an accident within a month are about 0.01, 0.03, 0.05, and 0.10 respectively. So minimum risk drivers, which I just highlighted in blue, have only 1% of chance getting into an accident next month. And then low risk drivers, 3%. And then moderate risk, brown. And then high risk, 10% of chance, respectively. Also, the company estimates about 10% of the customers are minimum risk drivers. Okay. And then 30% are low risk drivers. And then 50% are moderate risk drivers. And then 10% are high-risk drivers. Find the probability that a randomly selected customer of this company gets into an accident within a month. So, what are we looking for here? Getting an accident one way or the other. So we are looking for probability of one way or the other. Is that clear to everybody? Now, is there any probability of getting into an accident here? The answer is yes and no, not directly, but we have conditional probabilities. Conditional probability for minimum risk driver, 1%, low risk drivers, 3%, moderate risk drivers, 5%, and high risk drivers, 10%. So we have 4 different conditions and conditional probabilities. Is there any more? No, this is just classification. So, okay. So how does the accident actually happen? Here is the first key observation. Accident for minimum risk driver. Accident for low risk drivers. Accident for moderate risk drivers, and finally accident for high risk drivers. Let me do the color coding. Blue, green, brown, and then this is red. Does it make sense, everybody? the problem does not give you the probability for having an accident one way or other directly. This problem gives you a classification. Minimum, low, moderate, high. And for each class, we have conditional probabilities. You see, this 1%, 3%, 5%, 10% are all about accidents, but for different conditions. So these are conditional probabilities, not straight up probabilities. So if you like this, it'll be wrong. This will be wrong. These are conditional probabilities. Conditional probabilities for accident given minimum, accident given low risk, and so on and so forth. They are not accident and minimum. So this and that are different. What are these numbers then? Oops. It's these. Accident given moderate, accident given high. Let me go ahead with this color coding. Brown. This one's correct. This is wrong. So this is what we want. And this is wrong. The problem is not that simple. So wrong, so let me just get rid of it now. Now this is correct. So this is what we want. And that's correctly given condition. Now you have to use this to find these four. And of course, the rule that you can hold on to is the multiplication rule. The probability of A and B is a multiplication of probability A times probability of B given A. So these are all conditional probabilities. So you have to multiply something. And what are those to be multiplied? Is that clear? What are those to be multiplied? Can you find those from the second sentence for this problem? Or rather, third sentence of this problem? All those? Yeah? So, probability of minimum, 10%. Probability of low, 30%. And probability of moderate, 50%. And then probability of high, 10%. So, this is what we got from the second sentence. And this is what we get from the third sentence. Now, again, use this multiplication rule to calculate this one from these two. How do we do that? Well, here we go. This one is obtained by multiplying these two. Look at this multiplication rule. So A and B, this is event A and event B put together. So conditional probability times the condition probability. So this one here is 0.01 and 0.10, 0.01, like this. Oops. This one again is gonna be multiplication rule, so it's gonna be product of these two. So 0.30 times 0.03, multiplication rule. Same here, this is gonna be product of these two, multiply those two. 0.50, 0.05, and finally this times that is gonna be 0.10, 0.10, excuse me, I need this. And then if you calculate all that, you're gonna get what you want. And this is one way to handle it, and it is rather symbolic method. I must admit, not the best method, but I did it first here in order to get theoretical foundation first. Not the best method. Tree diagram method is better, but if I just give you the solution without the foundation, you don't really learn anything. That's why I gave you that. It's all based upon the multiplication rule. And then these problems are about finding this, given these two, using this multiplication rule. So that's what I did 4 times. Oops. There, okay. Okay, did I say this is not really the best method? There's a way to express the same idea graphically, and that is called a tree diagram. And let's see, it's one way to handle it. Not the best solution, but it works. So let's do that. And then let's work out the same thing graphically. And here is the tree diagram method. Now, all these probabilities are conditional probabilities after you know what kind of driver you selected. So these are second draw basically. If you compare this with EARN model, the conditional probabilities are second draw basically. You already know what happened, and from that condition you get the next draw. Now these are selecting those drivers at random out of the total pool. So this is a straight up probabilities. And that's where the high risk mod, low risk, minimum risk, all those are coming. And for each we have collision or no collision, accident or no accident. Getting this tree diagram is often difficult, but that's something you have to do. And now if you put all these numbers into this tree diagram, you're going to get this. Let's see. Minimum risk, 10%. Low risk, 30%. Moderate risk, 50%. High risk, 10%. Yes, those are straight up probabilities. Basically the first draw. And then for each, the second draw, collision or no collision. 10% chance of collision for high risk, 5%, 3%, and 1% respectively. And thus, the other 90% no collision, the other 95% no collision, the other 97% no collision, and the other 99% no collision, you can get complement probabilities here as well if you want to. See? And also, apply the multiplication rule. So here we go. So for example, minimum risk driver, we're basically following this path and then getting into collision. So what do? We just multiply this probability times that probability following the path. So each path represents a multiplication rule in this tree diagram, and in previous method we saw the foundation. It's based upon the multiplication rule, right? That's why this tree diagram method is actually working. Now we did it now, so in the future I'm not going to go back and do symbolic method. I'll come directly to tree diagram because you saw the connection between theory and practice. And this is for the minimum risk drivers. And for example, let's change color. And this is for moderate risk driver. And then eventually going into collision. So this multiplication of first probability times the second probability, which is conditional. Now if you have further tree diagram, then you just have further multiplication. Because as you saw before, the multiplication rule comes from this conditional probability. So if you just apply many more times, we're simply following the tree diagram more and more and more. Alright, the tree diagram is complete. Now here's the final answer. Probability of getting a collision one way or the other. First multiplication, that's for high risk drivers. Second multiplication, moderate. Third multiplication, low risk. And finally, minimum risk. Add them all together, we get getting into an accident one way or the other. And do the same thing for all those blue. No accident, no accident, no accident, no accident. And then please note that we end up with complement probabilities. They add up to 1. Okay, so much for the first example. As a matter of fact, this is not the first example. This is a third example, as a matter of fact, because in lesson 2, we already went through EARN models. So this is a third example of multiplication rules. I hope we now have sufficient practice before going over to Bayesian analysis, which will start in the next video. Stay tuned.